you're staring at your screen trying to make the smartest decision with your hard-earned money. So let's play a quick game.
Product A has a near perfect 4.9 stars but only 12 ratings. Product B has a slightly lower 4.6 stars but a massive 18,000 ratings. You have exactly 5 seconds to choose. 5, 4, 3, 2, 1. Okay, lock in your answer. Which one did you instinctively want to buy?
Look, if you immediately jumped at the 4.9 stars, do not worry. You aren't bad at math, you are just human. Online platforms use concepts like number anchoring and clever interface design to make that 4.9 visually dominate your screen. We see a near perfect score, and our brains just take a shortcut. We naturally assume it's the winner, while that tiny, almost invisible review count is doing more heavy lifting than the terms and conditions. But let's peel back the curtain and see what is actually happening. Let's look at the arithmetic, because it is honestly pretty fascinating. How did product A get that 4.9? Well, an average is simply total star points divided by the number of ratings. Let's say product A has 11 5-star ratings and just one 4-star rating. That gives us 59 total star points. Divide 59 by 12 and you get 4.9167, which rounds beautifully to a 4.9. But think about it, 12 reviews is not a crowd. That is barely enough people for an awkward birthday party. Now let's run a little one-review experiment. Imagine just one angry customer enters the chat and leaves a 1-star review for product A. We add those 13 ratings together, which gives us 60 points. 60 divided by 13 is approximately 4.615. Instantly, one single bad review forces product A to plummet to a 4.6. That score is incredibly fragile.
Now let's jump over to product B. This product has 18,000 ratings. That is literally enough reviewers to fill a small city. If it averages exactly 4.6, that means product B has amassed an enormous bank of 82,800 star points. It has an absolute mountain of evidence behind it.
So let's run that exact same one-review experiment here. We add that identical, angry 1-star review to product B. We now have 82,801 points divided by 18,001 ratings. The new average is 4.5998. Guess what? It still rounds to 4.6. That single, terrifying 1-star review barely made a microscopic dent. The displayed score is completely unfazed. This perfectly illustrates how averages really behave. Imagine a small bowl with just 12 white marbles. You drop one bright red marble in, and it changes the entire look of the bowl. It's totally obvious. Now imagine a massive container with 18,000 white marbles. You drop that exact same red marble in, and it practically disappears. So, here is the crucial takeaway. Small samples are mathematically fragile, while large samples are incredibly stable. Now, let's be really clear here. This does not automatically mean product B is objectively better, and it definitely does not mean product A is fake. A higher review count simply guarantees that the displayed average is highly stable and supported by substantially more evidence. It improves rating stability, not necessarily quality. Let's take this a step further because averages have a really bad habit of hiding secrets. Consider a completely different item, product X. It has 9 5-star ratings and 1 1-star rating. That averages out to exactly 4.6. But the distribution is totally polarized. Everyone either absolutely loved it or had a terrible time. That kind of split might indicate a rare but really serious manufacturing flaw. Compare that to product Y. It has 6 5-star ratings and 4 4-star ratings. If you run the math, that is also exactly a 4.6 average. It's the same exact number as product X, but tells a vastly different story. Product Y represents a consistent, drama-free customer experience without a single 1-star disaster. If you only look at the 4.6 average, you completely miss this crucial difference. And what about that shiny 4.9 average we all instinctively love? Well, let's say a product has 39 5-star ratings and just 1 1-star rating. 196 total points divided by 40 ratings equals an exact 4.9 average. This proves that a near-perfect score can still easily harbor one extremely unhappy customer. And if you actually read their written review, they might reveal a deal-breaking problem that ruins the exact way you plan to use it. Okay, let's level up to a boss-level concept. How do smart platforms handle this problem of fragile, low-review products outranking stable, widely tested ones? They use something called a Bayesian adjustment. Don't let the fancy name scare you. Think of it simply as mathematical gravity. It is a way platforms can weigh the actual evidence before placing a product at the top of your search results. Here is a simplified,
illustrative demonstration of how this works. Imagine the whole catalog of products averages a 4.2. We will call that the catalog average, and it acts as our starting anchor. Then, the platform sets a confidence amount. Let's say 50 ratings. This represents the amount of evidence a product needs before its own score can fully break free from that anchor.
Watch what this mathematical gravity does to our original products. Product A, with its fragile 12 reviews, just doesn't have enough evidence to fight the gravity. The formula pulls its adjusted score heavily down toward the catalog average, landing at roughly 4.34. But product B, with its 18,000 reviews, that massive mountain of evidence completely dominates the calculation. It easily resists the gravity and anchors safely right at 4.60. Now, an absolutely crucial disclaimer. This exact Bayesian formula is just an educational illustration. Please do not think this is the exact universal system used identically by every single retailer. Different platforms use completely different prior averages, different thresholds, and entirely unique ranking methods. But it perfectly demonstrates the logic of why rating count matters and how systems account for a lack of evidence. We also need to draw a hard line right here. It is so important to separate the math of small sample uncertainty from actual review fraud. Do not assume that every 4.9 product with a low review count is a scam. Oftentimes, a new product simply hasn't had the time to build a massive sample size yet. The math is just uncertain, not necessarily deceitful. Even setting fake reviews aside completely, there are incredibly practical reasons why a fragile 4.9 product might genuinely be a worse buy for you than a stable 4.6. The reviews might be wildly outdated. They might be referencing an earlier, better version of the product. You might see repeated specific complaints about a feature you really care about, or people might be evaluating it for completely different use cases than yours. So, how do we actually shop smarter in the real world? In this explainer, I want to leave you with the STARS checklist. S stands for sample size. Simply put, how many people actually contributed to this reading? Is it enough to be mathematically stable? T stands for timing. Are the reviews recent, or are you reading glowing praise for a model that was literally discontinued 3 years ago? Moving right along, A stands for agreement. Do the written comments actually match the star rating? If someone gave it 5 stars but wrote it broke on day 2, you've got a major red flag. R stands for range. Look past the average number and actually check the whole distribution bar. Are you seeing a consistent experience, or is it heavily polarized like our product X from earlier? And finally, the last S stands for sources. Do not rely on just one website's ecosystem. Compare across multiple platforms, look for independent reviewers, and seek out expert tests to find the objective truth. Treat the star rating as just one single piece of evidence, not the final verdict. So, as we wrap up, I want to throw a brand new challenge back at you to test your newly acquired mathematical intuition. If you were shopping right now, would you choose 4.8 stars from 50 reviews or 4.7 stars from 5,000 reviews? Think about the stability, the gravity, and the evidence. Which one really has the stronger foundation? I want you to explain your reasoning in your head. Because if you take away one single thing from this entire explainer, let it be this: never trust a number until you know how it was created.